can.
So apparently you guys have bookshelf in my class and food story.
Bookshelf on top of food.
Bookshelf?
Oh my god. It's good to know. So anytime I need snacks, I come to food story. Just kidding.
真太多。
Okay.
没有。
妈呀！我两边又不对称，一边碰到一边没碰到。天才呀，真的是规划上。
这练习完。
那长这样吗？再讲一下话。他说不要一次画全部这样。我是选这两个点。那我再多选一个。等一下。那我的差不了多少。
Everyone,
Yes.
look at the screen, please.
啊，我的完了。
Some of you have sketched some things, you're not sure if whatever you have sketched is correct. You are right. They have to meet at these two, they have to meet at here, and because it's now a function of degree, a polynomial of degree 4, remember this shape.
Okay.
Because some of you are wondering, oh, they have to meet here, they have to meet here, how do they meet? Yeah, they meet somehow. You know, maybe they chat on WeChat and they decide to meet somewhere. Starbucks, maybe. Yes?
They try to do this on Rasmus. I'm not really sure. They have to
What is the square of this? 16. So this dude has to start at 16.
，but they have to have
Nice.
I see what you mean now. No. Wait, what is the intercept of this?
So,
3.
X, Y.
That's 9. The turning point, 16. Yeah. Then, that's this. So it's going to come this way. 30.
I don't trust this guy.
Oh!
So it's just pretty big.
Yeah.
So they have to cross one and press one.
Okay. What about the functions that are neither quadratic nor linear? So everybody please pay attention. Everybody pay attention. Let's begin with maybe a rational function. Let's see. X minus 1 divided by wait, the ones in the investigation, let's go to that. Logarithmic, exponential. Uh-oh. What's going on? The connection is. Oh my god. I think I lost it. Is it because I'm not on my computer stable? Are you doing this to my computer? Okay, I'm back now. Tell it to work. Tell it to work. Alright, so let's look at this function. Let's pick from the 3rd to the 4th, 5th, and 6th. Okay, rational, exponential, and logarithmic functions. So let's take them one after the other. So let's take the rational function to start with. 2 divided by x. It's similar to what we've been doing anyway. Then let's look at the square of that, 2 divided by x squared. Oops. We're going to plot the x is equal to 0 is that asymptote, right? So I'm going to include that in the rational function. And we're just going to use the dotted line to denote that. Okay, so that's 1. Then after this, according to the investigation, 1 over x minus 3, let's try that also. Wait a minute, yeah. 1 over x minus 3, what's that?
Because when you were like the meeting, it would keep on changing.
Oh, okay. Isn't it amazing how they design something that makes this just work in real time? So, and the asymptote will be x is equal to what? 3. Yes. And there's no y asymptote is just the y x-axis, right? The horizontal asymptote. Okay. What are the exponential function? The exponential function we have here is, okay, so 2x and being dropped by 1 unit down, right? Okay. 2 to the power x, then 1 unit down, so this is the original function. So let's look at the square of it. Please, I need you to focus on the board. I don't know what these guys are talking about. Okay, that looks weird. But that's okay. We like weird functions. So the last one is logarithmic function, log x. Is that log x?
Yeah.
Okay, log of x. And log of x all squared. Come on, close the brackets. Okay, something like that. So let's see. Ooh, nice. Okay. Shush, 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 shush. So, observation.
The intercept x equals 0 and x equals 1.
Okay, so if there is x-intercept, it still meets there. But one thing is common. Y, whenever y is equal to 1, they meet, right? But not here. Oh, the green one is the function. Yeah? The black one is the inverse. So you can see that the inverse only stays in the positive y, right?
The square.
The square. The square only stays in the positive y. So that is why when this guy is here, now this has to be here, right? So it's not like that. Then both of them have the same vertical asymptote. Do you agree? Both of them have the same vertical asymptote. And that makes sense. If the original function is going to be, it will not exist when the denominator is equal to 0, then even the square is the same. So that makes sense, right? What else do we notice? Let's look at some of this one. Okay, we can see the same thing here. Okay. I'm looking at a function. Maybe I put a function that has a different, that have both horizontal and vertical asymptote. Let's see, because this has a bunch of y-axis, x-axis as our horizontal asymptote. What if we have a function like 2x minus 1, minus 1 divided by maybe x plus 1, something like this. And clearly you can see that this is y is equal to 2 is one of the asymptotes, and x equals minus 1 is the other asymptote. Okay? Now let's look at the square of this function. Can you see the square? Projector mode. Let's look at that. So the asymptote, please, I need your attention, please. So the original function is the red. Okay? Even if without the equation you can see because it's on the negative side. The square will not be on the negative side. Again, do they meet at y equals 1? Yes. So they always meet at y equals 1. And whenever the original function has x-intercept, this dude also comes along. Okay? And if it doesn't have it, then it doesn't come. But here, there's x-intercept, so the dude is there. What about y equals 1? Yes, they do. Can you see? Somewhere at 10. Can you see? It still meets there. Okay? What about the y-intercept of the function if there exists any of such? Let's look at this. The y-intercept of the original function is what? Minus 1. And the square function, the y-intercept is plus 1. So we still have some of the similar properties, right? Now I put some additional properties in your notes. I put to you what happens within minus 1 and 1. What is the behavior of the square function? Do you see that on the screen? Between minus 1 and 1, can you see that one is closer to the x-axis than the other? between minus 1 and 1. If such a function exists at that point, right? Look at this. Which one is closer to the x-axis? The square. Check what your notes. Check what I wrote in that paper for you. Did you see that? And outside this interval, it is farther away from the x-axis. Okay? Outside the interval. Okay? So between minus 1 and 1 is closer. That is guaranteed. Outside that interval, at any time from here, you may not have that. And you can see that it started from 2. The only reason that we have that up to here is because they are meeting somewhere here. But you are guaranteed that any moment from here is gone. Am I making sense? Let's look at another function. Look at this also. Look at your square function. The square is the block, isn't it?
Yes.
Okay. And both of them, yes, the black one seems closer here. Seems closer here. Okay? Even though it also seems closer at this point, but one thing that is guaranteed at this point that yes. But after this region, the more you go, the farther it moves away. We're not saying it is closer than the other one, but it starts moving away. Am I making sense? Okay, so go back to the original one also. Outside this region, it starts moving away from it. Look at this one. Do we have the same property? The green one is the square function. Look at the green one within minus 1 and 1. It's closer to x-axis than the other one. And outside the region, it starts moving away from it. Okay? So that is one property. Did I leave out any property? I think every other property we've discussed, right? They touch the x-axis at x-intercepts. The graph also touch, lies above, it's always above it. We've talked about that. Yeah. Y, 0 and 1 is always invariant. It means they are always there together. Any questions? Okay. So for this one, we will not spend time in the class doing the exercise for the others. I'll just give you the paper. Please brainstorm among yourselves. In some cases, I put the equation of the function. In some cases, I did not. Okay? So you can see me to check if it is right or not. You do your best. Let me have your sketch. Then I can chip in 1 or 2 things that you have not. But anytime you do a sketch, remember those key points. Just watch out for your y equals 0 and 1. Watch out for your x-intercepts. And the rest will be easier to do. Okay? Because once you know those key points, and you can remember, oh, within this range, it should be closer to x-axis, then you should know how it's going to move, and the rest is a sketch. It doesn't have to be perfect. Okay? And you can use the trick that it taught us. If you look at the original function at a particular point, then look at the square function as the square of that point. Maybe that will work in some areas. Okay? All right. Here. I wanted to pick one and pass the rest. So what I want us to look at now is the other thing that I've included in that summary paper because of our time, please. So please, whatever paper you are taking right now, and whatever paper you've had before, please just, you can scan through 1 or 2 minutes, but please do not do anything. What I want you to look at is now the functions, the modulus of a function, and the function of mode x. I'll go back again. Absolute value is also what we call modulus, all right? Miss V, I'm going to write something here. Special months is around the corner. Parents should not forget that. Never mind. Absolute value. function. Of course, we all know what absolute value means, right? So I already put it in the paper. Absolute value of x, or some people say modulus of x, that's fine, is just the distance from x to 0. And you don't talk about positive or negative when we're talking about distance, right? So you cannot say, okay, I'm here now. Listen, everybody. Look at Krista and I are the 0 points. You are 1, she is 2. You are negative 1, you are negative 2. Is it right to say Lillian is negative 2 away from me? You still saying Lillian is 2 units away from me. But on the negative side, now that's direction. Now you are speaking in the vector language, because you have to consider both the magnitude and the direction now. Am I making sense? Similarly, her, you would not say she's plus 2 units. Just say she's 2 units away. Absolute value works like that. It's a distance function. A distance from 0 to that particular unit. So absolute value of x is that distance of x from the 0, from the origin, as the case may be. So that is why it is defined as this. If x is positive, like 3, definitely absolute value is just x. If x is non-negative, let's put it that way. So if x is 3, absolute value is 3. If x is 4, because 4 is more than 0, absolute value is 4. If x is 9, because 9 is more than 0, absolute value is 9. If x is 0 itself, absolute value is 0. But if x is negative, you use negative x. So that when x is, so absolute value of negative 3, because this value is here. Are you with me? Then you use this definition. So there's a standby negative of this. Am I making sense? And what do you still get again? That's the meaning of this definition. The idea is for you to get non-negative. So if it is a negative, negate it. If it is positive, just copy and paste what you see. That's what is happening. So because it's a distance function. Okay? So we're interested in graphs of absolute value of this. Regardless of what this guy looks like. What if, no matter what this looks like, what will this look like? That's one part. Another part, I've summarized everything in that paper. Another part is, no matter what this looks like, linear, quadratic, cubic, quartic, whatever, rational function, exponential, logarithmic, we don't care. No matter what it looks like, what does it look like if we take the absolute value of the arguments and not the function itself? So there are two parts to it. Okay? So what we are going to do is try to plot some graph so we can understand what we have written down in those papers. So I'm not giving you as an investigation because I do not want us to waste time. Let's just look at it together. After that, I compiled some worksheets in form of a booklet and I'll share with you, and that's all. This is even easier than the square function, so no worries. Okay, so let's look at the first one. Hi neighbor, I'm back. That is my neighbor now. Let's look at the linear function. Everyone, x minus 1. Yes, please. What? I didn't get that.
No, just the office. You want to go to noise?
Oh, yes, please. You alright?
Head kind of hurts.
You should have stayed at home, dear. I got an email, he's sick. What is he doing in school?
He lost math.
How can you know? That's weird. You know, somebody did that last year. Was it last year? Yeah, I think so. I'm trying to remember who did that. And came for math. Yeah, that was you.
Remember 1 year?
You're supposed not to be in school. Maybe you're supposed to go for a camp. And you only came for math.
Oh.
You see, that's how I should have known that I'm teaching a bunch of weirdos all along. I should have known.
I'm pretty sure.
Alright, everyone listen. Everyone listen. So this is the original function. Shh. This is the original function. Now let's look at the absolute value of this function. Oh, no, that's not absolute value. Aye. Okay. No, not you. Okay, it's you. That's it. Absolute value. Oops. Come on in. Who's there?
No, it's
No,
not.
it's not
here. I took off my glasses and I realized that was because of them.
Well, I don't know what he's talking about. Okay, everyone listen. Okay, everyone listen. Look, so that is 1. Well, we don't know what is happening. How about we check quadratic? Okay, I'm going to leave some of this so we can test them. Okay. Quadratic. I wanted quadratic to be the next one. So we can look at it in that order of complexity. Okay? Clarissa, are you paying attention? Are you sure you're paying attention? Okay, just smiling as usual.
It's so pure, I can't see anything.
Oh my God. You see, as much as I love you, I don't want to be as weird as you are. So are you sure you're not going to transfer that weirdness to me, sitting close to me, dude?
We'll see.
We'll see. All right, so let's look at this. Absolute value of that. Are we seeing something? Maybe, maybe not.
Yeah.
How about when we take the modulus of the x alone? Something weird happens. Okay, I'm going to leave this out so we can summarize. Is anyone seen a pattern already?
Only that.
A negative probability of reflection.
Yeah, someone is speaking the reflection language. That's one of the patterns. Good. -1. Let's see. Not you. Get out. 2 to power absolute value of x -1. Boom. Where are they? Oh my God. Okay, so let's begin with the first one. I'm going to take, oh log. I love logarithm. Okay, let's consider Mr. Logarithm. He's a nice guy. Okay, just copy this. Lazy people, paste it. Yeah, you can judge me. I don't mind. I'm lazy. Actually, do we even need to take the absolute value of x in the logarithm function? Yeah, maybe we do. Because x can't be negative, right? X can't be negative.
There's an error.
Yeah, I don't know why it's giving me that.
I think it's because it's already
Maybe. Okay, what's the information here? Use parentheses around log. Okay, how about we use parentheses? That guy said use parentheses. We're going to use parentheses. Then let's put absolute value. Yeah, we're smarter than you are, dude. Okay, here we go. All right, let's change the colors so we can see them clearly. And maybe this one. Well, this one, maybe we use the dotted ones. Okay, so the original function is blue, which is now behind that. So let's start from the linear. Now this is the linear. The original function is green. Shush, please. The absolute value of the original function is that. What do you notice? Let's remove this. Let's discuss does the absolute value alone. Projector mode, please. Thank you. Let's remove the third one, just the absolute value. Okay, first. Are you seeing something here?
Yes.
Okay, is this part of it? No, get out. We don't need you. Okay, so what do you notice?
If
Anything
the
below
absolute
0
value goes under the x-axis, it is the reflection of the x-axis.
Reflection on the x-axis for some parts.
And for
The part that is what?
under
Below 0. Okay? The part that is below 0 gets reflected along the x-axis. That's just a trick for the absolute value function. And the reason is we don't want negative part. So anyone that comes positive, dude, you're okay. Right? You're free to pass. Negative, sorry, you're gonna have to change the way you look. We like weirdo in our class. You don't look like a weirdo. Something like that. Okay, can you see? Then it gets reflected. Reflection. The negative part becomes a reflection in the x-axis. Can you see that? The reflection. So it's easy, isn't it?
Yes.
Now let's look at the other one. So what do we notice? This looks like they are exactly the same, but not. Now look at this. Did you see? There's a difference. Here the negative part get reflected. Here, not the negative part get reflected. Some part get reflected. Which part get reflected?
The Y.
So there's a reflection in the y-axis now. Oh. There's a reflection in the y-axis now. Let's look at the other shape. Did you see?
Yes.
The red is the original function.
Oh.
So anything.
I was thinking, where's the reflection at?
That's it, yeah.
The
Because,
green part. Oh.
because anything up to here gets reflected.
Yes.
Okay? Do you know that actually makes sense? Up to here means you only consider x greater than 0. And that makes sense. Look at what you did. Okay? You don't let your x be negative. So your x negative doesn't really have a say. Hello? So anything from x equals to 0, there's a reflection on the other side. Let's look. The black one, right? Can you see? Again.
Yes.
Okay? The negative part of x is a reflection of this one. And finally,
Okay.
same, right?
Yes.
So you're going to keep the original function up to here. Then you do the reflection on the other. So basically there are two. For the absolute value of the original function, you reflect in the x-axis. For the absolute value of the argument of the function, you reflect along the y-axis.
Yes.
Okay? So again, this deals with x equals to 0, line y equals 0. The other deals with line x equals 0. There's a similarity. Am I making sense? And that's all I want us to. So when I give you this paper, try to do as much as you can.
It's similar to this one. But if you only do negative or
Before we go, try to do both absolute value of the function and absolute value of the arguments in random order. You don't have to do everything, all right? Mr. Chen, I left one on your desk. She doesn't share, unfortunately. Too bad. She's so mean. Can you pass to them, please? There are two there. Is that coffee? Oh my god, that smells so good.
you can't smell it.
Yeah. Which means my mask is not working, right? Because I'm not supposed to smell it.
Do you drink your coffee black or with milk?
Both. It depends if I want to get drunk or not. If I don't want coffee, I try to put some milk and just tea light. But if I want to like stay awake, I take the black one. With just sugar, definitely with sugar. I have sweet mouth.
Sugar makes it worse though.
I have sweet mouth, trust me.
Sugar makes
Who hasn't got one? Where's the last? I left one on your table already. Then this is good. Why?
I don't know, I just like don't like coffee.
So it gets bitter. Oh my god.
Like
Coffee. Oh no, I don't want coffee. So make some attempts on some of them. Yeah, for the first two you will see one for absolute value of the function, one for absolute value of the argument. Okay? I try to do that for different questions.
Why?
y 要正的，所以就是特别 x。
No, not again, not again. Hi. Okay, got it. It's not. No, I mean, okay, sorry.
所以你是
Wait. Perhaps it's about the function you don't have. No. But this is y not negative. You're not supposed to have that. So you're actually doing the opposite, like this one. So any part that is already positive, don't touch that part. Yeah, only that you need to include.